أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Dear students, today we will study about Romberg's integration to find the value of integral from a to b f of x dx. We have studied some numerical techniques like trapezoidal rule, Simpson's 1/3 rule, Simpson's 3/8 rule, and so on to find the value of this definite integral. Now in this lecture we will learn about Romberg's integration to find the value of this definite integral. So let us start. What are the basic steps for this technique, Romberg's integration? First of all, we'll see that you will be given an integral just like integral from a to b f of x, and we need to find the approximate value of this definite integral with the help of Romberg's integration. The value of n will be given to you people. That is the first thing. I mean this a, that b, and this f of x along with the value of n. These four values will be given to you. Now that is the same step that we have followed in the previous lecture, that a, b, f of x and n will be given to you, where n starts from 0 and so on. And secondly, you need to calculate the step size h, and the step size will be calculated by this formula b minus a divided by n. The new thing in Romberg's integration that we need to calculate h prime. This is h. H is actually the step size, and h prime is not the same as step size, but h prime is actually the difference between these two limits, upper limit minus lower limit, b minus a. So we need to calculate h prime along with this h, along with this step size. Thirdly, we need to construct a difference table as studied in the previous lecture. If that difference table is not given to you people, with the help of calculator to get the values of those xi's and the values of those f of i's. That is the third step. The fourth step is we need to find the series of sums. This is the new thing in this Romberg's integration, that we need to find I11, I12, I13, I14 and so on. These are called the series of sums for Romberg's integration. How could we find these i's? That is the formula. That formula will be given here in the form of a table. So whenever we obtain the values of these i's with the help of these given formulas, the other step is we need to find different order Romberg's integrations, t's. These will be obtained by some specific formulas. And how could we find these Romberg's integrations? That will be given here in the form of a table. And the other step is write these values. We need to write these values, the values of these t's, the values of this Romberg's integration in the form of a table. Now lastly, the values of T14, T24, T34 and T44 are always same up to the desired accuracy. 1, 4, 2, 4, 3, 4, 4, 4. These values will always be the same in desired accuracy. Now look at here. How could we find I11? I11 will be calculated by this formula. I11 is half of the first value of f plus the last value of f. So adding these two, the average of these two is actually I11. Secondly, I12 will be calculated by this formula. I11, which you have obtained from here, I11 plus f of a plus h prime by 2. F of a, this is the function f of x. So we need to replace x by a plus h prime by 2. What is h prime? H prime is actually b minus a, upper limit minus lower limit. So we need to replace a by its own value and h prime by its own value, divided by 2 and adding these two, and we will see that which value of function is assigned to this value of x. So that is I12, sorry. Thirdly, we need to calculate I13. How could we calculate I13? I13 will be calculated with the help of this formula. I13 will be calculated with the I13 will be calculated by this formula. I12, this I12 plus f of a plus h prime by 4, that was h prime by 2, I12, and this thing is a plus h prime by 4 plus f of a plus 3 h prime by 4. The multiple of h prime are odd numbers. I mean, there is 1, then there is 3. So that is 1 h prime by 4 and that is 3 h prime by 4. So that is I13. And the fourth one is I14. I14 will be calculated by this formula. That is the formula for I14. That is I13, this I13 plus f of a plus h prime by 8. You see, this is the multiple of 2, that is 2, then 2 2s are 4, then 4 2s are 8. So that is f of a plus h prime by 8, and here is the odd multiple of h prime. Here is 1, so the other one will be 3 h prime by 8, the other one will be 5 h prime by 8, and the last one will be 7 h prime by 8. So summing all those values, you will get I14. So those are the formulas for those i's, I11, I12, I13, I14. Whenever you calculate these values of i's, the other step is we need to calculate Romberg's integrations, the values of t's. What are these values? These are the values. We see here that t11, just like I11, then t12, then t13, and then t14. If we look around here, n is equal to 8. Whenever n is equal to 8, we will extend t up to 1/4. That is the half of that 8, that is 4. So these are 1/4. Now other thing is, whenever you calculate these t's, then replace these ones by 2. So just like t11, so that will be t22, then t23, then t24, that is 4. So that is t24, and then replace these 2's with 3's. So that is t33, and so in the same way t33, then t34, extend it up to 4. So that is t34, then increase this 3 with one more point, so that is 4, and so that is t44. We see here that is t11. We have started from t11 and extend it up to t14. So start from t11, extend it up to t14, then start from t22 and extend it up to 24, not exceed this 4. Okay, so that is 24. Then start from t33 and extend the second digit up to 4. Then the last one is, that is t33, then start from T44, and that is being extended up to 4. So the values of these T11, T12 and so on are given in this row. You see here in this row, these are the values for these Romberg's integrations. T11 will be calculated with the help of this formula. I mean, T11 is H prime into I11. You have calculated H prime from there, and you have calculated I11 from there. So put these two right here to get T11. And the second is T12. T12 will be calculated by this formula, that is H prime by 2. H prime by 2 into I12, this I12. T13 is H prime by 4 I13. You see, that is 1 1, so this is I11. T12, so this is I12. T13, that is I13. T14, and that is I14, along with H prime, and that is H prime by 2, then H prime by 4, then H prime by 8, the multiple of 2. 2 2s are 4, 4 2s are 8. These are the values up to T14. Now the rest of the T the values of these Ti's will be calculated with the help of these previous values. T22 will be calculated with this formula, T12 plus 1 by third time the same T12 minus T11. T12, the previous value of T12 is 1, T11, so that is T12 minus T11. T22, 23 and 24. If that is 22, so here is 1 2. If that is 23, so here is 1 3. When there is 24, so there is 1 4. 1 less than this 2. 1 less than this 2. Just look at here. If that is 2, then this is 1. The second digit, the second suffix is the same, 2. Whenever there is 2, so here is also 2. So that is T22 is equal to T12 plus 1/3 time the same T12 minus T1 and 1 less than this digit 2, which is 1 1. So with the help of this formula, we will calculate T22. Now this one is T23 will be calculated. This is 2, so that will be 1 less than this suffix 2. So T13, so T13 plus 1/3 time the same T13 minus T1 and 1 less than this 3. This is 3, so that is 2. However, this is the formula for T23. T24, so this equals to 1 less than this 2, that is 1, and the second digit is the same. Second digit is the same. We see here that T24 up to T24, that is T22, 23 and 24. All these values of T's included 1 by 3 here, 1 by 3, 1 by 3, 1 by 3. There is also a general formula to calculate the values of these T's, but you don't need to remember that formula. You just need to remember these simple formulas for these T22, 23 and 24. So that is the same multiple of T13 minus T12, the same multiple of T14 minus T13, and the same multiple of T12 minus T11. Now when go towards t3, 3, that multiple will become 1 by 15, 1 by 15. So 1 by 15, 3 3 and 3 4 contains the same multiple 1 by 15, 1 by 15. This is t2 3. So here this is 3, so one less digit is 2, so that is t2 3 plus 1 by 15 times the same t2 3 minus 1 less than this 3, that is t2 2, that is 3 4, so that will be 2 4 plus 1 by 15 times t2 4 minus t, one less digit of this 4 from this 4, which is 3, so that is t2 3. And the last one is 4 4. Whenever there is 4, the first digit, t4 4, so that is the multiple of 1 by 63. This is the difference, 1 by 63. So t4 4 will be calculated by one less digit from this 4, that is t3 4. t3 4 plus 1 by 63, the same t3 4 minus one less digit from this 4, which is t3 3. Anyways, these are the values to calculate the values of these t's with the help of these formulas. Now we need to write these values of t1 1 1 2 1 3 1 4 2 2 2 3 2 4, and these all values in the form, write these values in the form of a table as just like this one. We see integration sums are there, I1 1 1 1 2 1 3 1 4, these are the integration sums, and in front of these integration sums we will write t1 1, then t1 2, t1 3, t1 4, and then between these two values t1 1 and t1 2 we will write t2 2, start from here, t2 2, then t2 3, then t2 4. Now the third column is, we need to start these values t3 3 and t3 4 between these two values and these two values, and between these two values we will write here in the fourth column the last value t1 4. So this is the table that we need to write the values of all those t's in the form of a table just like this one. We see here this diagonal t1 4, t2 4, t3 4 and t4 4. The values of t1 4, 2 4, 3 4 and 4 4 are always same up to the desired accuracy. The values of these t's, this diagonal, the last diagonal, from the last value up to the first value of this column, these values will be always equal to some desired accuracy. So this is the this value will be considered the approximate value of this definite integral. This definite integral will have the value which have the values for these definite integrals. Now let us start to solve an example with the help of Romberg's integration. And this slide, we see in this slide that now let us start to understand the idea of Romberg's integration with the help of an example. The example is that using Romberg's integration to find the integral, find this integral from 1 to 2.6 1 by x with respect to x, and the value of n is given to you, which is 8. So that is the whole story about this example. This data is given to you, and you need to find the approximate value of this definite integral when n is equal to 8 with the help of Romberg integration. So let us start the solution. The solution is we need to compare this integral we need to compare this integral, the same integral, with the integral from a to b f of x dx. Whenever you compare these two, we will get a is equal to 1, b is equal to 2.6, and 1 by x is actually f of x. So f of x is 1 by x. A is equal to 1, b is equal to 2.6, and f of x equal to 1 by x. N is given to you, which is 8, so n is equal to 8. So all these four values are given to you. Secondly, we need to calculate the value of h, the step size, by b minus a divided by n. B minus a, this b, 2.6, minus this a, which is 1, divided by n. N is equal to 8. So whenever you calculate this fraction, you will get 0.2. So h is equal to 0.2. And secondly, you need to calculate h prime. H prime will be calculated by upper limit minus lower limit, b minus a. So b, this is b minus a, so that is 1 by 6, 1.6. So remember that the value of h is 0.2, but the value of h prime is 1.6. Remember these two values. The third one is we need to construct a table for this function with the help of calculator. How could we construct a table with the help of calculator? I have explained this in one of my lectures. You can check it from there. So whenever we construct a table starting from 1 up to 2.6, starting from 1 up to 2.6, we need to take a step size of 0.2. So that is 1.0. Adding 0.2 with this one, you will get 1.2. Then again adding 0.2 with this number, you will get 1.4. Then 0.2 adding 0.2 with this number, you will get 1.4. Then 1.8, then 1.2.0, adding 0.2, so that is 2.2. Adding 0.2 with this number, you will get 2.4, and then 2.6. And the corresponding value of f of x for this value of x is this one from table. Whenever you construct the table, you will get f of x equal to 1.000, and this and that and that and that. Now what are the values of x0, x1, x2? These are the values of those xi's. That is x0, this is x1, this is x2, this is x3, and the last one is x8. So x8 is equal to 0.2.6. And what are those values? Those values are actually this value is actually f of 1.0. Just look at here, that is x, so this is f of x, so that is 1.0. so this is f of 1.0. f of 1.0 is 1.000. This f of 1.0 is actually f of naught, f0. Whenever that is x0, so that is f0. And this is actually, this value is f of 1.2. This value is f of 1.4. This value is f of 1.6. This value is f of 1.8. This value is f of 2.0. This value is f of 2.2, and this value is f of 2.4. The last value of the function is f of 2.6. All those function values will be denoted by, this is f0, this is f1, this is f2, this is f3, and so on and so on. So these are the function values. Remember these things. F of 1.0 is 1.000. F of 1.2 is 0.833. The same thing is f of f1. I mean, this value is actually f1. If this is x1, this is f1. So this is f of 1.2. F of 1.2 is 0.833. F of 1.4 is 0.714. F of 1.6 is 0.625, and so on. So try to understand these notations. We will use these notations to complete these questions. Okay. Now the first thing is we need to calculate these sums I11, I12, I13, I14 as discussed in the steps taken in the Romberg's integration. I11 will be calculated by this formula. That is the average of first value of the function f0 plus last value of the function f8. This is f8. So this is half of f0 plus f8. So half of f0 is actually 1.000, so replace it, and f8, this is f8 is 0.385. replace this f8 here, sum these two values and divide it by 2 to get this answer. This answer is actually I11. This is I11. Now second thing is we need to calculate I12. The formula for I12 as discussed previously is I11 plus f of a plus h prime by 2. I11 is actually 0.6925. This is I11, 0.6925 plus f of a from here, a is equal to 1. So that is f of 1 plus h prime. This is h prime. H prime is actually 1.6. This is 1.6. This is h prime. So replace h prime by 1.6 divided by 2. 1.6 divided by 2 is 0.8. And whenever 0.8 is added with 1, you will get 1.8. So that is f of 1.8. This value is from there, that is 0.6925 plus this plus f of 1 plus 1.6 by 2 is actually f of 1.8. Now what is f of 1.8? You check here, f of 1.8 is 0.556. so replace this f of 1.8 by 0.556, and adding these two values you will get this answer. This answer is actually I12. This is I12. Now the third thing is I13. This is the formula for I13. I12 plus f of a plus h prime by 4 plus f of a plus 3h prime by 4. Replacing all those values, replacing I12 by its own value. I12 is here. I12 is 1.2485. So we have replaced I12 by 1.2485, and we have replaced a by 1, h prime by 1.6 by 4, then again plus f of a is 1 plus 3h prime by 4. So 3 times h prime by 4. Whenever you calculate this sum and this sum as well, you will get this thing 1.2485. this is from there, and 1.6 by 4 is 0.4. 0.4 plus 1 is 1.4. so that is f of 1.4. you see here, f of 1.4, that is from there, and 1.6 divided by 4 is 0.4. 0.4 multiplied by 3 is 1.2. 1.2 plus 1 is 2.2. so that is f of 2.2. so we need to replace f of 1.4 and f of 2.2 from table. F of 1.4, this is f of 1.4. f of 1.4 is 0.714. so we have replaced f of 1.4 by 0.714, and f of 2.2 2. F of 2.2 from table, f of 2.2 is actually 0.455, so that is replaced by 0.455. Adding these three terms, you'll get this answer, and this answer is I13. We have calculated I11, I12 and I13. Now the last thing is we need to calculate I14. I14, the formula for I14 is this one. That is the formula for I14. I13 plus f of a plus h prime by 8, then 3h prime by 8, then 5h prime by 8, then 7h prime by 8. Replacing these values, we have replaced I13 not here, but we have replaced a by 1, h prime by 1.6, h prime by 1.6, a by 1, h prime by 1.6, a by 1, and here as well. Whenever 1.6 is divided by 8, you'll get 0.2. 0.2 plus 1 is 1.2, so that is actually f of 1.2. Just look at here, 1.6 by 8 is 0.2. 0.2 multiplied by 3 is 0.6. 0.6 plus 1 is 1.6, so that is f of 1.6. And from here, 1.6 by 8 is 0.2. 0.2 multiplied by 5 is 1.0. 1.0 plus 1 is 2.0, so that is 2.0, and the same thing is here. So that is I13, f of 1.2, f of 1.3, f of 2.2, and f of 2.4. Searching the values for these f of 1.2, 1.6, 2.0, 2.4 from table, and the previous value of I13, so we have replaced I13, f of 1.2, f of 1.6, f of 2.0, f of 2.4, and adding these terms to get this answer. This answer is actually the value of I14. So we have obtained the value of I14 in this manner. Now the next thing is we need to calculate the values of t's. You see, t11, the formula for t11 is h prime into I11. Replace h prime by 1.6. Replace h prime by 1.6 and replace I11 by its own value, and multiplying these two to get this answer. This answer is actually t11. Secondly, we need to calculate t12. t12 is h prime by 2 into I11. H prime is 1.6 divided by 2, and I12 is 1.2485. Dividing these two and multiplying it with 2.6 to get this answer. This answer is of t12. t12 is this thing. The third one is t13. t13 is h prime by 4 into I13. Replace h prime and replace I13 and calculating this answer to get this answer. This answer is actually t13, that is t13. And the last one in this sense is t14. t14 is h prime by 8 into I14, that is h prime, and this is I14. Calculate this this value to get this answer. This answer is actually t14. So these are the formulas for these t11, 12, 13, and 14. Now t22. t22 is this thing. We have studied that the formula for t22 is this one. I mean 1 less than this 2, so that is t12. t12 plus 1 by 3 times the same t12 minus 1 less than this 2 is 1, minus t11. Replacing t12, this t12 is this one, this is t12. Replace t12 by its own value, plus 1 by 3, so that is plus 1 by 3. T12, the same t12 is here, and minus minus, this is minus T11, this is T11, see here. So replace T11 by 1.1080, 1.1080, subtracting these two and dividing it by 3 and adding it with this number to get this answer. This answer is actually the value of T22. So that is T22. And the next one is T23. What is T23? 1 less than this 2, so that is 13, T13, plus 1 by 3 times the same T13 minus T1, and 1 less than this 3 is 2, so that is T12. Replacing T13 by 0.9670, this is T13. T13 is 0.9670, so that is 0.9670 plus 1 by 3, plus 1 by 3, the same T13, the same T13 minus T12. T12 is 0.9988, so that is 0.9988. Subtracting these two, dividing it by 3 and adding the answer with this number to get this answer. This answer is actually T23, so that is T23. Now again T24 is this one. Replace T14 by its own value. This is T14. T14 is 0.9585, so that is 0.9585 plus 1 by 3 times the same T14 minus T13. T13 is actually 0.9670, that is 0.9670. The answer is 0.9775, and this answer is actually T24. Now T33 is T 1 less than this 3 is 2, so that is T23. This is T23 plus 1 by 15 times the same T23 minus 1 less than this 3, so that is T22. Replacing T23, this is T23, and T23 is actually this number. So replacing T23 by this number plus 1 by 15 times the same T23, the same thing, minus T22, and T22 from here, this is T22. T22 is actually this thing, so replace it here. Calculating this sum, you'll get this answer, and this answer is of T33, so that is T3. And next one is T34, is this formula, considering in the same manner and calculating in the same manner to get this answer, and then T44 calculated in the same manner to get this answer. So these are the values for these t's. Now the last step is we need to write these values in the form of a table, You see here, writing all these values in tabular form, in table form, that is the table form. These are the values for sums I11, I12, or you may say interval here 1 2 3 4 and 8, that is I11, I12, I13, I14 actually. Now these are the sums. This is T11, trapezoidal sum, T11, and this is T12, T13, T14. Now first order is, this is T22. Between these two, this is T22, and between these two, this is T23, this is T24, and next column is, this is T33, between these two here, T33, and this is T34, between these two values, and this thing is T44, between these two values, T44. Now this is this is T2324, 222324, T24, T34, and T44. Just look at this diagonal. Just look at this diagonal. these answers, these values are are same up to 4 decimal places. So we may say that we see that the diagonal values, that this is the diagonal values agree up to 4 decimal places. So the answer for this integral in our question is actually the same answer, which is 0.9557. So that is 0.9557. So this is the methodology to calculate a definite integral, to find the value of a definite integral with the help of Romberg's integration. So with the help of Romberg's integration, the answer will be a bit close with the real with the exact answer. If you try it, if you calculate the exact value of this integral with the help of calculator or with the help of a pen and a copy, you will get an answer which is very near to this answer. So I hope that